Yeah, this is a Makie hands-on. I decided not to give like a very basic introduction to Makie, but instead show off some cool new features I've added for the web-based backend. But yeah, I still wanted to have a little bit of an introduction to Makie here and talk a bit about what it is. So it's a plotting framework, mostly written in Julia. I guess from its scope, it's a bit comparable to matplotlib or any other plotting library like that. It has a bit more focus on interactivity and visualizing large data in 3D than other plotting libraries. And it has this kind of backend system to support multiple use cases very well. So on a desktop with a GPU, you want to use glMakie for high performance visualization. If you're wanting to turn your plots into a publication, there's chiroMakie, which helps you export vector graphics like PDF and SVGs. And then for the web, there's WebGL-Makie that's based on WebGL, like in the name. And there's a experimental ray tracing backend, which is really nice for creating stunning high fidelity visualizations. Yeah, it works for 2D and 3D. And I just inserted the cheat sheet from Lazaro, which I think should give you a very quick overview of like the scope of Makie. What it's like able to do. It should be animated, I guess, to really show the full scope, because yeah, as I said, quite a bit of focus in Makie is that it's easy to interactively visualize things. There's quite a bit of an ecosystem around Makie, also because it's kind of designed that Makie is like the core tool with a relatively low-level API, and that other people then write their own packages to make it easier to use in different domains. So, for example, there's algebra of graphics, which gives Makie a kind of ggplot interface to make it much easier to do statistical plotting. There's GeoMakie, which is not as stable as other packages, but it's a start. And I hope starting here with all the geo people, we can figure out a way to maintain it a bit better. But I will actually use it in the talk to make a little Earth visualization. We already mentioned the great website from Lazaro with a ton of incredible examples that should really help to see how to create beautiful plots with Makie. And there are quite a few more little things, like GraphMakie is pretty well maintained, I think, at this point. And you can make pretty amazing visualizations with it. Wait, there's some pretty cool ones, like where you can just animate graphs and interact with them. And I think it also has like a graph editor where you can move around the edges and stuff like that. There's also one that builds upon GraphMakie. So like already like a second layer above Makie for visualizing street data, OSM data, which has been seeing quite a bit of improvements since the last time I checked. I don't think it had this fancy menu here before. And yeah. And the docs, obviously. So they're all under this umbrella of the Makie.org domain. But yeah, I think to really get started, the first steps in Makie and how it works, when one should just look into the docs, and I will concentrate on showing a finished plot and some cool stuff around it that I've recently developed. But I also wanted to talk a bit about the backends, because it's fairly unique, I think. So Makie itself, the package just defines a backend independent language, you could say, to specify how the plot should look, and then the backends actually draw it. And Makie is the first backend that I developed. It has a lot of code inside that's very old from my beginnings in Julia, where I dabbled with OpenGL and high performance visualizations and 3D animations. It has quite a few basic UI elements, which are quite usable at this point. So you can make little simple dashboard to explore your data completely inside a desktop window. Yeah, but it does need a GPU, so it's not usable for all use cases, even though you can set up a virtual GPU on most headless servers or anything like that. But you might want to use a different backend in those cases. Makie uses Cairo to draw this Makie plots as vector graphics. It has very high 2D rendering quality because it doesn't have the speed requirements that Makie has. So it has a bit better anti-aliasing and things like that. And yeah, you can export it to PDFs and put it in your publications directly. It also is able to do 3D plots, but it's a bit experimental. There are a few things that don't work as well, like in the other backends, because yeah, we need to do our own 3D drawing inside a format like PDF that's mostly for 2D or SVG actually. Yeah, but it runs everywhere. It runs on the CPU, so it's I think a lot of people use it as their default backend because it's also a bit faster to start and things like that. WebGL Makie is the after RPR Makie. It's the latest backend that I added. It creates visualizations in the browser via 3JS and WebGL. So part of it are written in JavaScript, but it also uses a large part of Makie, which is written in Julia. It works quite similar to GL Makie because it's also based on WebGL, and Makie is based on OpenGL, which are related, which is basically just the browser API to do things on the GPU. So it can actually be fast for visualizing a lot of data, but animating it is a little bit slower because you need to serialize the data in Julia, send it to the browser, and then deserialize it in JavaScript, which is quite a bit of overhead depending on your data. It's pretty feature complete, but there are a few random things that are just not implemented right now because I didn't have the time for it, like marker strokes and line joints. It's a bit random, but that's how it is. Because the browser takes care of running everything on the GPU and always having a fallback if you don't have a GPU. I think it runs almost anywhere. And yeah, so it's great for working if you have a huge simulation on a server that doesn't have a GPU and you want to interact with it on your local machine, then WebGL Makie is a great tool. And the ray tracing backend is very new. It's pretty much just a prototype, I'd say, at this point. Mostly just supports the 3D primitives of Makie. Sadly, it only runs on Linux and Windows right now, which I hope might be solved by just upgrading the dependency. It's very slow, but that's part of ray tracing. That's just a very slow process. So, but that means you need high-end hardware for high quality animations. I think on a 380, so a pretty recent fast GPU, it can take up to 30 seconds to create a nice looking image. But yeah, if it works, it looks pretty nice. And I hope it can be used in the future to make really nice looking visuals of some interesting data sets. Yeah, I want to concentrate on WebGL Makie because I just improved it a lot in the recent months, and the capabilities to use it for making dashboards. And yeah, I just realized I kind of skipped the hands-on part. So we tried to prepare Docker images and the data set, and we iterated over it quite a bit, and now it's a bit confusing. So I decided we'll just upload one good way to do it in the end, and nobody needs to follow it live. If you already have it running, of course, feel free to follow it and play around with it. But yeah, I won't explain how to set it up right now. So I want to show off a visualization I made for the climate machine for their simulation data of the Earth and atmosphere. It looks like this. Oh, it's a bit cut off. Can we? Why is there such a large gap here? Oh yeah, that's better. So here, this is a 3D visualization of the same data just on a sphere. It has multiple levels in the height of the atmosphere. It has it's a time series, so of the simulation. It has multiple fields like pressure and things like that. And yeah, I want to introduce you to this observable concept here, which is the main way, one of the main ways in Makie to create interactive graphs. Basically, what you can already see here is that there's this one simulation plot function that takes all these observables here. And the concept of observable is relatively simple. It's just like wrapping a value, and then you can register on the updates to that value. So whenever you update a value in Makie, I can register, I can run functions on every update. So if I update this here, you see I changed the field, I changed the level and the time, and now the plot updated. And this is a very fast way of updating things, because, for example, in a lot of plots of large data, you might want to change the color, but it's or the positions of particles or something like that. And updating the positions of particles is kind of expensive. But for example, changing the color can be very cheap. So you want to have them separated. And by using these observables for the color, for the position, or for the field, or things like that, you can kind of separate these and update them like more surgically. I think a lot of other plotting frameworks have gone down the road to just replot everything. So basically, instead of passing in observables here, they would just call the simulation plot functions every time something changes and start from scratch, basically, which is, for large data, can be a lot slower depending on what you need to do. But yeah, so I wanted to give a quick start with how you use observables. So you already saw you can just construct it for the value that you want to pass. And then you can map over the updates and get back a new observable of a function that gets applied to the new value. So this observable that you get here will always be this observable +1. And you can also just register a function on any update of +1, for example, without creating a new observable with the on function. And if you update another observable inside this on function here, it's pretty much the same as the map functionality, but that's what you use if you don't actually want to create a new observable. And then there's also this connect function that I will be using, where you can connect one observable with the other and forward all the updates to the other observable. Yeah.
So since it's hands-on,
sure.
It's okay. I was wondering, I used to write this with a @lift macro, I think, something.
Oh yeah.
To that effect. So this would be the new, better way to do this.
Actually, it's kind of the other way around. So Julius introduced the lift macro as a convenience function, so it's newer. But I'm kind of old school, I guess. I just use the map directly. That's that. So this comes from observables.jl. And this is the original API from observables. And the lift macro was added to Makie. So Julius just added it to Makie, and I think it's a bit nicer and more terse to write, but it can also be confusing to people that don't know the macro. So if you're reading the code, but I don't know, maybe the map is also confusing to people. But just to show you how it would be done with the lift macro. So this is just like the inside of the function, basically, and you can write it more directly. And any observable in there needs to be interpolated here with this sign. But you can also use other variables that are not observables if you don't use the sign here. So if you would do this, it wouldn't work, because then it would just make 1 plus the observable, and the observable doesn't have any function like plus overloaded. Yeah. So yeah. That's true. Yeah, I'm not too happy with that situation. Inside Makie, I use lift everywhere because it's easier to refactor, because map is such a generic function that can be anything, and lift is really just for observables. So it makes it easier to immediately see. But yeah, for this talk, I just wanted to stick to the observable basic API. Yeah, so JSSurf is a package I've written to create WebGL Makie. So it's a package that allowed me to communicate with JavaScript and actually implement that you can pass observables across the language borders. So JSSurf basically is a framework with observables at its heart, where you can just pass them into an HTML or JavaScript DOM, and it will update in JavaScript. So this way you can register on the JavaScript side, you can register to these updates. And JSSurf also makes it very simple to create HTML DOMs and insert some JavaScript in there. I just made a very small example here. Here you can see that, yeah, DOM gives you all these HTML tags. So if you're familiar with HTML, this should be very simple to start with. Of course, the syntax is a bit different because we can't just copy the HTML syntax directly in Julia. So it's having this kind of, yeah, function syntax here. But the keywords should be all the same that you can pass, and they should directly end up in the HTML like expected. Yeah, so just to make something bold, you could use CSS or directly pass this HTML style attribute. And did I run this? Yeah. And yeah, JSEarth also already wraps a few of the HTML standard widgets, like the range input, which I usually call slider. I think it's kind of funny in HTML terms, slider is usually a slideshow of images. And yeah, a slider that I'm familiar with is a range in HTML, but anyways, I stick to what I'm used to here with the slider. So you can quite easily create a slider with JServe. It returns you this new type, which has a field with the value, which is an observable. So you can connect it to other observables. And if you actually put it in any div or in any HTML DOM, it will render the slider. And then you can actually, like this, update these observables. And I think this is pretty nice for writing UIs for visualizations, because you kind of separate the visualization, the plot, from the UI. Yeah, which is kind of cool, because someone might write this function simulation plot in a package for their simulation software, and then anyone can write a UI for it to explore it. Yeah, so here's a very simple first version where I use these JServe widgets to actually update the simulation visualization. And I did a bit of a funny thing here, because as I told you, Makie also has these widgets like sliders. And the new thing is they also work now in WebGL Makie. So any GL Makie UI or dashboard you've written should also work now in WebGL Makie. It's a bit slower because it needs to do this round trip over Julia to JavaScript. So it's not as smooth, I would say, as it is in GL Makie. But this one is the one that actually is just like a plot. And this one is a HTML widget. So this here is just a canvas, basically, where Makie does all the drawing and plotting. And this also shows you that you can just insert a Makie figure that I created here anywhere in the DOM, and you can also put inside multiple figures inside an HTML document. That means if the Makie layouting isn't enough for you, you can also switch to HTML layouting pretty much. Obviously, I'm not very good at HTML layouting here. Or I actually wanted to keep it simple, because otherwise I would have tried to align this here. But yeah, this also shows you that you can update these plots from very different UI frameworks. That means if you're more familiar with GTK or Qt and already have things set up there to make these kind of UIs, you can use that as well to just update these kind of visualizations. Yeah, so, but that means there's a choice. Makie offers UI widgets, JSurf offers UI widgets. So when should you use which? And what speaks for using the JSurf widget is that HTML has been used for this for years and decades. So they're very mature, they're very customizable. It's very easy to make a super fancy slider or a very fancy layout and things like that. And you can, in JSurf, you can use any JavaScript library or CSS library or HTML library inside your project. So you could just start using Google's Material UI or things like that. So the choice of what you can do is much, much larger. And obviously, if you want to actually have your dashboard end up on a website, you should go the web route. And yeah, you can put together with JSurf fairly complex JavaScript interactions that will stay active on a web page that doesn't run a Julia process. As I said, like WebGL Makie is kind of driven by Julia. So if you kill Julia and have it on a web page, the interactivity will go away because it can't actually get the updates from Julia anymore. But yeah, you can actually also update the plots inside JavaScript directly and write JavaScript for it. But it's of course a bit more tedious. And why not? So WebGL Makie, as I said, is not as fast and feature complete as GL Makie. You must run it in a browser or Electron, which is not always desirable. You might just want to have a nice little desktop window, which is native. And yeah, there's no way around paying the cost of serializing your data. So if you have millions of particles you want to visualize at like 60 frames per second, you won't be able to do that in WebGL Makie. Yeah, so now I'm using the whole range of JSurf widgets to actually complete this kind of input that the visualization has. So I have a slider for the time, I have a slider for the level. I can choose the field here. So we have kinetic energy, potential temperature, and so forth. And we can actually choose a projection. And now I also have a toggle to actually show the Earth overlay. Oops. And yeah, I have these sliders here. And I just want to say, so I said a lot that WebGL Makie is slow, but this is quite a bit of data here and it's pretty smooth. So I think it's definitely usable for quite a few use cases that you can think of. Yeah. But this is very basic here. This is how it has been the whole time with JSurf. I now want to make things a bit easier to make it look fancy. I worked a bit on styling these widgets a bit more, and I wanted to show you a bit how this can work. So there's this JSurf asset type that allows you to include any kind of other existing library for styling or for JavaScript. And one of my favorite libraries for easily styling your UIs and HTML is Tailwind. And JSurf actually ships it, so you can just use it directly. It's just like, yeah, shipped within the repository. And if you insert it anywhere in the DOM, it will be loaded. And JSurf also takes care that it doesn't get loaded multiple times. So if you actually depend on it in your own code, you can just insert it all the time to make sure that it gets loaded before you actually use the CSS classes from it, which I'm using here to style this a bit. Tailwind has very nice documentation, I think, which makes it very easy to quickly make like layouts and things like that. So where is it? Yeah, makes it very easy to do these kind of more complex layouts by just adding a few classes to your HTML. And that's what I did here. I think there are two basic ways of extending JSurf. So if you want to write like a little style dashboard package in Julia, I would recommend two ways. One is just like writing functions that return HTML, these DOM fragments, basically. And then others can use these to style their application and make it a bit easier. So here I made a little more styled slider that allows you to have a title and actually see the value and make it look a bit nicer. And you see here, I need to now in this function return the slider and the HTML I actually want to display for the slider. Which is not always what you want. So there's a second way of doing this is by creating a new struct. So I called it here style slider. And I just have the slider in here and the HTML that it should display in another field. And then I can overload JS render to actually display it, insert it into the DOM. And that's also how Makie, WebGL Makie inserts these figures into the DOM. So Makie just overloads JS render and emits the correct HTML to show the plot. But this way you can just have the style slider here, insert it into the DOM or do something here with slider value whenever it updates. So these are kind of equivalent. The function one I use usually for prototyping, and then when I kind of want to offer it to other users, I get more serious by actually creating these structs and overloads here. I've written a little widget library like this here, which I want to add to JSurf. So this is really at the edge of development, basically, because JSurf is still not very highly advertised because the docs aren't that polished, and it doesn't have these easy ways to make styled dashboards. So I haven't been advertising it a lot, but I think I will do this in the next month and have a release with all these widgets in there, which make it very easy to create a bit nicer looking dashboards. And now if you put this into action, it looks a bit nicer. It's more readable. You have like titles for the different things. The layouting is a bit easier with these row and call list widgets I've added, which makes it very easy to align them and put them in there like this. So I think this is already a pretty basic and pretty simple dashboard you can do. And if you look at the code, it's not that much work to actually set this up. Yeah. Any questions so far for this widget dashboard part? Okay. Then I want to show you a bit how what you can do with this app. I kind of didn't really mention like why do we wrap this always into this app. It has several reasons. First one, it makes it easier for me to display it in Jupyter, for example. But there's also another big reason for it. It's that you can serve it on a web page, and that means every user gets their own. Everyone that goes on your website looking at this dashboard needs to get their own version, right? Because they play around with it. It needs to be global. And that's kind of the reason why it's wrapped here in this app thing, because that means this one should be an isolated unit, right? But that makes it very easy to just serve this to your users. So JServe just exports the server that you can hand in the app. And since I'm here on Docker with Jupyter Lab, it's not super straightforward to host it and visit it in the browser, because yeah, you kind of need to have this proxy URL here. And that's what I need to set manually here. I think this is a bit more of an advanced topic, but with this, it actually works to just serve this on an URL. And if you have your server set up correctly, this could be, yeah, anywhere on the web. And then you can show this to your users. You just need a server that has a running Julia installation, basically. And there are a couple of other ways to do this. So there's the static export that creates just static HTML files without a running Julia server. As I mentioned, that means you don't have all the Julia interactions anymore. And if we go here, we see what it exported. It exported 2 HTML files. Just to show off that you can have like these routes, I did a very, very simple app that just takes you to the other app here. And if I export it like this with multiple routes, I actually need a static file server, which can be just like what GitHub does, for example, on GitHub Pages. So if you put this on this folder on GitHub Pages, it should just work. Locally, you can serve it with, for example, Live Server, which just serves the files that are in the folder. So here you have this. But as I mentioned, all these sliders work in Julia, right? They load data in Julia and do the updates in Julia. So these are not working anymore here. What does work still is the camera, the 3D camera. So you can zoom around here in 3D. That's just because I already implemented that in JavaScript. If I have time, I want to do that with more primitives in WebGL Makie. So for example, that you can do the 2D zoom and that those kind of things stay interactive once you've exported it without a running Julia process. And there's also a prototype how to kind of cache what Julia would be doing. So you can record a state map for every state of the slider, get the values that Julia would produce, and then load them whenever you move the slider. So I made a third demo of how to export an app that runs everything in Julia, caches all the states, and then creates an HTML page that will still stay interactive after exporting it. And I think that's here. If it's a single HTML, I don't actually need the file server. I can just directly open the HTML. I can share it in an email. I can, put it on GitHub or wherever and should just work. This is taken from the docs. This example from the WebGL Makie docs. So you can see the 3D camera is interactive. And all these state updates here are cached. So this stays interactive. And this way you can make very simple plots stay interactive even after this kind of static export. But yeah, it's a bit experimental. As you can imagine, if you have a lot of sliders and a lot of states, the combinatorial explosion happens and you will generate gigabytes of data, which will maybe crash your browser or just will take a long time to load. There are a few ways to help with this. I'm not sure how much time I will spend on making this route better, or if I will just move more things to JavaScript in the end. Any questions for this? Yeah.
In which format do you save the data for the plots?
That's WebGL Makie's own format, pretty much. What I do is basically just create dictionaries of the Makie plot objects and convert a few data types that are not describable in JavaScript, and then send them to WebGL Makie.
I was just wondering if you can save it in binary format to make it more efficient.
Yeah, it's already saved in binary. So I've actually put a lot of time into making this this communication with Julia as fast as possible. So this uses the connection with JavaScript uses message pack and compression to make the updates as small as possible and as fast as possible. So I think, yeah, as you can see, this is quite a bit of data and it's pretty smooth. I think Lazaro wanted to show one example that's a bit slower, like when you have a so Makie has several 3D axes, and one of it calculates everything in Julia to figure out where to place the labels and everything, and what to display in the axis. And this gets surprisingly slow because it needs to do so many things in Julia and then send a lot of updates to JavaScript. So, yeah.
I have another question, if I may ask.
Sure.
So you're mentioning converting some Julia function to JavaScript to make it exportable. So what is your idea about WASM, where you have like C and Rust can compile down to WASM? There has been a fork of Julia of 1.3, I think, which was also able to use WASM, but not.
Yeah.
So is this the future, do you think? Or is really
yeah, so compiling
time?
Julia through WebAssembly would nicely solve this issue. Then we could just compile it, everything to JavaScript, and everything would just stay interactive and would just work. But I think we are quite a few years away from this. There are a lot of little problems that need to be solved, and there's nobody working full-time on it. And I think even if we now had someone working full-time on it, it would take quite a while to make it usable. I wondered if we could have like little functions that just get transpiled to JavaScript so that you can make a few things a bit easier. For example, we have this data inspector in Makie to get like hovers over your data. And a lot of times you kind of want to transform the data that gets displayed before you actually show it to the user. And this one would be a small Julia function that gets transpiled then to JavaScript and stays working pretty much. But I think, yeah, that will already push it because it's kind of complicated. So I think right now I'm trying to make the other ways smooth. Because I don't know, it's probably 5 years away or 4 years away to compile Julia to JavaScript. And then it will be a different game. But until then, I think we need a good solution to do these kind of things.
Work into this JS serve, and it's very good news. It looks really powerful, and interacting directly with the DOM is, I think, a fantastic idea. So where do you see this going? You also mentioned that you're going to put more work on these next months or so. Where do you see this going?
That's a good question. Yeah, I mean, I guess it should go into the direction of Shiny or things like that. And I really want to prioritize that people very easily inside Julia can show their data and share interactive ways to show their data on the web or wherever. I don't want to say it should become the standard way of doing it. It definitely will become the standard way of doing it in Makie, I would say. Although we are working, JServe is very flexible in the way it communicates with the front end and the way you can actually insert it into other apps. You can just export fragments of your application and put it somewhere else. So JServe should also be able to integrate into Genie and or other apps that come up in Julia. So yeah, I try to make it as flexible as possible so that it has a nice road to the future for Makie being able to be displayed anywhere.
Yeah, basically in any HTML.
Yeah.
Irrespective of what other frameworks are running behind.
Yeah.
Yeah. Awesome. Thank you.
Cool. Thanks. Yeah.
I just have a question regarding the loading of data when you're plotting it, especially when just now when we're seeing that we loaded the time series data, you've loaded like 10 different days at the same time, and then in the serve, when you're doing the JServe, you're just using the JServe to select which part of the array it's being plotted. Mm-hmm. Is it necessary to load all the data at one shot, or is it possible that you could basically, because especially for climate data, if the climate data is very big, you may not have enough memory to load all the data at one shot. So is it necessary to load all the data, or can you just load a certain time series using and then use do you have basically, my question is, do you have to load all the data at one shot, or is it possible in some way to load one part of the data at one shot, one part of the data?
I don't think that's Makie specific. I think you should just be able to use a memory mapped array or like a lazy array type. I think there are quite a few that got presented here. And if you switch that out, you won't need to load the whole data. So that's just because it was easy for me. I'm not that familiar with all these lazy arrays that make it possible to work with data that is larger than the RAM. But yeah, I think the Julia offers a lot of tools there, and you can just use them with Makie, of course.
Okay, thank you.
Thank you for the presentation. It was very, very interesting. You mentioned you had to solve the transport of data from Julia to the browser, to the JavaScript runtime. So can you talk a bit further on how you solve that and what different methods did you find? I remember like there are the binary transport protocols like gRPC or tRPC. Have you looked at those? Thank you.
I haven't looked at those. It's actually, I think, the first time I heard of them, but I looked at the at all the popular JavaScript binary protocols, and there weren't that many that were mature and fast. So I ended up with MessagePack, which in all benchmarks seemed to be the fastest. And that's kind of how I got stuck with it. There are a few, it should be relatively easy to swap out. So I think when there's something else that seems promising, it should be just a couple of days work to actually swap it out. And then I will do it if it's worth it. Yeah, that's cool. I will.
Yeah. So I was wondering about the source of data that you're using. From kind of eyeballing it, it looks a bit like a kind of a coarse resolution model output. I was wondering what the resolution is, and maybe you can say something about the models that was used.
I actually can't. It's from the climate machine. And I have no idea about the model, to be honest. They just gave me this time series to make a visualization for it, pretty much. And I didn't dive into how it got produced. But it's open source, so this example. It's part now of the Klima Makie core package as an example. And maybe you can look there for further information.
Do you know like the size of the arrays, for example, by and large? Wondering if it's 100 by 100 or if it's like 1,000,000 by 1,000,000. You know?
No, it should be something in the thousands, I think. Oh geez, it wasn't that easy. So actually yeah, I don't know. Maybe you should just.
Okay. No, it's okay. Thank you.
I don't think Klima's climate model, I don't think they run it at super high resolution. So it's probably 512 by 256 at the max at this point. Yeah, that's based on what I know.
Yeah. I can send this around later. Yeah. Yeah, that's a good question. I mean, that should make put the performance into perspective. Yes. Yeah. I guess it's timeout, although Lazaro might not use all the time, but maybe then we can move it after he's done. Any more questions? Okay.
Okay, so as I referred before, we are now having a hands-on session on visualization of Earth observation data with Lázaro Alonso. Stage is yours.
Like this.
Yes.
No, I have
okay.
but I need some water. No.
Does it work? Hi. I think it's displays. Range. Yeah. Apologies for the delay. It doesn't work. Probably need another one. You have another one?
Tens algum confessor de aquele que se usou ontem? Onde é que está o que se usou ontem? Aquele que se usou ontem.
I mean, I can see that the text thing here, but
Yeah, it recognizes something.
Yeah.
That's- Tries to connect, but
that says that doesn't, right?
it's not today. Not today. Aí está.
Flickering.
É que eu estava a fazer o flicker.
It's okay.
Really?
Really? I think it's okay.
O adaptador que eu estava ontem.
É este.
Esse adaptador.
É o último.
Okay, while we fix this, I wanted to ask who has Julia installing their computer? Okay. So it will be okay for you guys if you go to the repo and clone it and just work in your computer locally. Because I mean, in my computer, the Docker image didn't work, so I will not be using Docker at all. I mean, but you could use it as well, and it should work there also. But I would like to actually do the coding live, so that you can actually follow line by line and see how things are done, at least for my simple examples. Okay, it's not that complicated, but still, I need to say aloud, right? Is it my computer or is the?
No, the Max. It doesn't like.
It doesn't like the Max.
Max
Okay.
ones.
So can I borrow someone else's computer? A Linux one? I don't know.
Try this one. Oh, this. Try this one, but probably that one is
Eu acho que estes
Because I also have mine here. Yeah.
pode ser de computadores.
No signal. Yeah. Doesn't work. Let me try again. Yeah, it used to work. I mean, I use this all the time. I use this all the time at home. So. No.
This one is equal, but it's. I think the problem is with the max really.
Yeah.
This connection. Do we have a plan B?
I mean, I just need a computer. Yeah. Let's see how long we have. Okay. Yes. So today, yeah. Better? Even better, yeah. So thank you for having me. So today I will talk mainly about data cubes and how to visualize them with Makie. But before going into the topic, I just wanted to show you this project that I have been doing with Makie, where you have different climate visualizations. So you can actually go here to this webpage, which is on GitHub, and click on some of them. And here you have live examples that actually just work here. Okay. So this is the thing that Simon was talking about before. So you can actually customize the whole thing pretty well if you know a little bit of JavaScript, HTML, and Makie all together. So yeah, just wanted to show you the things that you can do. Yeah, small detour, which is okay. As for this workshop, the material is in JuliaEO in this subfolder, but if you don't want to clone the whole thing, it's also here in my account, so that if you want to work locally, you can also do it with this folder, or you can do it in the Docker image. It's supposed to work on all Linux machines, so all the steps that I'm doing here, they should work, okay? And if they don't, then we talk about it afterwards, and we try to fix it for your specific case. So the topic, data cubes. So these data cubes is part of a bigger project that we have at the Institute, which is called DeepCube. And DeepCube is a research project that aims to explore and develop new deep learning approaches to address relevant Earth system dynamics. So basically, we are looking at droughts, heat waves, and migration flows, if any there. And the goal here is to collect a lot of data with high resolution. These cubes here are 30 meters. So each pixel will represent 30 meters. And apologies by the figure, but we sample a lot of them, like 50,000 of them, all across Africa. Because this is the use case for this project. So this is the thing that we have. And this work has been recently presented in New York IPS 2022, so just last year. And yeah, if you want to know more about it, you can go and look for this, learning to forecast vegetation, greenness at fine resolution over Africa. And it's also in archive, and you can see how this is actually used there. As for the coding part, which is the thing that we are doing today, it's just grabbing the data and doing some heat maps and some cubes, which are like these ones here. So if you have the folder with the manifest and the project, you can instantiate that, and things should just work in iJulia. So I will be using different, okay, all these packages, not really, just from here to here. The first two I will not use, but we could use them if, yeah, if it's needed. So in the normal workflow in the Jupyter notebook now will be to call WebGL Makie activate that backend, usually you should have this line, because usually you will have the different backends while you are doing your data analysis. At least that's how I do it. I mean, I have Makie, GeoMakie all together, and sometimes I switch between them just to have like quality, a picture that I need for my publication, or do I need the interactive one to do the exploratory analysis? As for data, I usually have JAX arrays and the netcdf package plus dates. And I use these packages to open netcdf files as dataset cubes, I call it. We call it like that, where you have like longitude, latitude, and time, and you will have different variables within this dataset. In this case, because the target for this project was to investigate the greenness, we calculate a vegetation index called NDVI. The details doesn't matter, but yeah, it's called NDVI. And in this case, because we were trying to do some predictions with some LSTMs, you will have your target and your prediction. So within this data set, we encapsulate all these variables. You can see here you have your target, and then you have your predictions. And I just display here the content of each one of them. I must say that this information here is lazy, so you don't have the data actually in memory. So you can just grab the things that you need before you plot. Just as a simple case, I just go for the longitude, latitude, and time, because I will use these variables later on. And as a simple example, I start with a heat map, which is the simplest thing to do with this kind of data set. So for this heat map, first you define, okay, there are different ways to do it, but the way I did it here, I just did like a color map, a global color map that I will use everywhere, and a global color range that I will use everywhere in this notebook. So I put it at the top. And the names here, color map and color range, are keyword arguments in the Makie functions. So when you pass this to the Makie functions, it's enough to just say color map and color range, okay? And that's why I did it. So in this case, you start with your figure, okay? You define your figure, you define some resolution. And then in this case, I say, okay, I will need 2 axes because I want to plot target and prediction. So I define my 2 axes, like 2 columns. So I do a for loop, easy. I put some labels for the longitude and the latitude. And then I simply say heat map in my first axis, the target for time 1. Use the color map that I define at the top, use the color range that I define at the top. Then the second step, I do the same for predictions, and that's basically it. If you want some extra changes to your plot, as this hide decorations function is pretty useful, so that you hide the decorations for the second plot. So that's the workflow that I usually do. Or most people should do. Like if you are having the same y-axis, you should not show the ticks as well, right? Okay, in this case, the labels. And when you pass this keyword argument here, tick equals false, just means that you should keep the tick here in the second plot. If you don't pass this one, this should go. And this is dangerous now because it's live coding. So you don't see the ticks anymore, right? And this last one, which is call gap, will take your full layout and reduce the column gap, the gap between the columns, to 0. So you don't see any gap there, right? If you change this, then I'm supposed to have, yeah, a space between them, okay? Then you can pass, again, your ticks equals false so that you can keep the ticks. You can do the same for labels as well, and other arguments. What did I did now? Yeah, it's in high decoration. Sorry. Yeah, it's here, right? Thank you. So the pretty cool with this now, with this backend that I'm pretty excited, is that you can actually do a zoom in here in the heat map, and you can see all the details that you want to. This was not possible before, I think, some months ago. I was not able to do it, but now you can do it. Now we have an error that is good that happens now, because now Simon knows that there is an error here. I zoomed too far, right? So you should have like a callback, like stop. And now, because this data set contains 10 time steps, the next step could be like, I want to plot all the 10 time steps as heat maps. So the next step that I did was to define this layout where I plot all the heat maps with this arrangement. And it's pretty the same workflow as before. I define my figure, I define my array of axes in this line here. So you have your array of axes in this line here. And then you just say, do me a heat map in each of one of these rows, right? I mean, for row one, do me 10 time steps. So do me 10 heat maps. Then for the second row, do the same, which are the predictions. Then I do the same as before. I hide the decorations. Now for column 2 until the end, so that you hide all the Y decorations. And then you say, for the X decorations, hide all the ones for row number 1. Okay, so that's the thing that you can see here at the bottom. You don't have any decorations for the Y-axis from column 2, and you don't have any X decorations for row number 1. What else? Yeah, there are several options where you can change the Y label, the X label, and you can even put a title based on the time. And we cannot see here the far right, so that's why I changed the number here to have a smaller image. So now I run it. Let's hope that it works. And we wait. So by the way, doing this in the new Julia version in 1.9 beta is pretty fast, so I don't need to wait any time. But now I need to wait. Why do I need to wait so much, Simon? Is this actually what? I mean, for each, yeah, for each heat map is only 128 pixels. It's not that big, but now it's been super slow, which I don't know what is happening. Yeah, the Docker didn't work at all with me, and was pretty slow. It's not running. This one here, right? It died. Oh no. Maybe I just need to kill it, right? Yeah, I don't know what's happening here. Okay, I'm not afraid to kill things. So I will kill the kernel and I will kill the whole session and I will start again in a minute, okay? Just see if it works. And if it doesn't work, then we try again another day. So if you have this in your computer locally, it should be working.
Something?
Yeah,
I forgot a few things.
a few things. Yeah.
Okay, I'll use this time to show something that I forgot.
Yeah.
Okay.
Yeah, so I tried to run the hands-on notebook that you made, and it worked great in the browser, but it did not work for me in Visual Code with the sliders.
Ah,
Is
yeah,
that
that's not
like a
expected to work
issue,
yet.
or is that something that's?
So every platform has their quirks or IDE. So Jupyter, Pluto, VS Code. It cost me a lot of time to get them all working, and VS Code I haven't done yet.
Okay, okay, that makes sense.
Yeah, I just wanted to quickly show two things. So first of all, this exactly same code that I included in the notebook works pretty seamlessly also with GeoMarkie and looks kind of the same. And I actually started out with having this as a GeoMarkie UI. So with the Makie native widgets, basically. Oh, it needed a bit to compile, I think. So yeah, you can swap these out pretty interchangeably. That's something I just wanted to quickly show. And another thing that I actually saw today is that it's a pretty historical day for Makie. Because we actually are just about to become the most starred plotting library in Julia. We took over plots.jl half a year ago or something like that in May. And now we're going for Getfly, and I think there's just 1 star less than Getfly. So if anyone wants to make the star, then we can overtake Getfly. Cool. Awesome. Yeah. So Getfly is one of the oldest Julia plotting libraries. I don't think it's actually used that much anymore, but since it had such a, you can see like time just helps with stars. They just go up usually. But yeah.
That was it?
Yeah.
Good. I will try to change to GeoMarkie now. Okay. Yeah, it's not interactive.
Okay.
Good. So I will continue with the functions. Unfortunately, they will be done with the other backend. So yeah, I will go back to GeoMarkie. So I will use GeoMarkie now, which is also interactive. Okay. So, I mean, this is the beauty about Makie also, that if one of the more experimental backends doesn't work for you, then you just go back to the ones that you know that work. all the time. Now it's taking too much to load. Yeah, we're good. So I will rerun things and we will see the output, because I actually want to show you the cubes. So that's the whole goal of this, right? So now we run this one. I already explained the code, and let's wait for the first plot. So just in case it doesn't display figure. Okay, while we wait for the first plot, takes a while. It's okay. Yeah. So if I call display, as Simon mentioned, I should get a screen with the plot. This is always an issue when you do the live coding, right? You just prepare the whole thing and you don't run anything. Looks awesome, right? Yeah, I don't know why I don't see this here. Okay, never mind. So the other way of plotting this data could be like an unnecessary 3D plot, right? I mean, you don't need it. I mean, I could do all this heat map as a 3D plot as well. So in order to do that, I define a grid of points with these dimensions, okay, which are the dimensions of my heat map. And because I want to use a rectangle as the marker, I mean, to actually have each one of these points with a value, I define this marker here, which it just takes as coordinates my point of origin and the size of this marker. And because I need the values from my my array, I reshape the whole thing to a one vector of values, because that's the thing that I need to pass. So if you run this line here, you will have a full vector of points, and here you will have a full vector of values. So when you do that, you run that, and then in order to do up a 3D plot, you use this axis LSScene, where you pass your figure position, and then you just simply call mesh scatter to your axis, the points, the marker. And now the marker size, it's important that in marker size, you pass all the values for each one of the points, so that you can actually see also the effect of the actual value for each one of them. And the other keyword argument is a color. So you need a different color for a different value. The color map that I defined already at the top, and the color range. Then you run this, and you should be able to see a new plot here. So which is a 3D plot that does, I mean, necessarily is useful, but you can do it. I will try again to do this display figure. Like, now it works. So you can actually have this interactive window here and do the zoom in, right? And explore your valleys in your data. I mean, you actually don't need it, but yeah, you can use it. The other axis that I really like is this called axis 3, where you can plot exactly the same data, but it has some more keyword arguments that allow you to have like the labels and a title, and yeah, like the elevation, perspectiveness of the plot. And it's pretty pretty handy to have this axis 3. So you have it here. You can also explore your data as a 3D object. Okay. So, and you see, it's pretty simple data. It's just a heat map. So the only trick here was to generate the points, to pass the marker, and to pass the values. That was it. Something that I really like here is that you can use this axis and pass 2D functions as the heat map, this one here. So if I run this one, this function here, I have my axis, and then you can see here that I'm saying in this axis, plot the heat map of this array. And the default is to put the heat map in the X, Y axis, okay, at 0. And this suggests that you can use heat maps in 3D, right? And that you can position them in different places. So if you go to the interactive window, you can see where this heat map is located at. So regarding transformations, then you have this keyword argument here, which is called transformation. So you play with this one, you will see where this heat map will be located now. So this is a transformation in the Y Z axis, and this second argument is the location. So the location is at 0. So you put it here, okay? And this is for the first time step. And you can do a simple for loop and put several of them, right, in different locations. So in this, So in this case, it's at 0. So the next step that I did, I was like, okay, I have 10 time steps, and I will just simply pass my index for the time and the position from 0 to 1 in this range. And if you do that, then you get all the slices of the heat map over this axis cube, I will call it now. So if you want to go to the interactive version, you see display, and then you have this display here of your heat map. Okay, it's pretty cool. I like it. And as you can see, this was the heat map over each pixel, right? But then, just for the fun of it, you can also do this with scatters, specifically with the mesh scatter. So you can take each one of the pixels and associate a single scatter for each one of them, and do also a 3D plot of the whole thing. So as before, you define your points for the 3D space in time and X, and in this case in Z, because you want the points to be arranged in this fashion, right? And then the marker, you define a marker for this. Notice these values for the marker. I usually use minus 0.5 to 1, such that the marker is centered at the value 0 in this case, right? So the center for this one will be 0. So it's at the center of the value that I want to plot. And since I already have the values for my array, no, I do the values here below. Yeah, so you use the same function, the same call function, and the only thing that changed now is the points that you're plotting and the values associated with each point, which in this case I'm passing as the color. Okay. Then you run it, and then you get this. Let me show the display. And then in the display, you will get this kind of cube, which is made of individual mesh scatters. rectangles in this case, right? So you can see here, I don't know if you can see it, but you can see how they change from one to the other, right? And you actually can change the marker size so that you can actually see this effect. 0.8, let's say. Then I will just display here. I don't want to type it twice. Display. And here you can see that they are actually individual boxes. Okay. Yeah, that's it basically. And Makie has, yes.
Thank you. Yeah, this is awesome. I was wondering whether you were considering, well, you had considered sort of just plotting the sides as heat maps, like 6 heat maps, and sort of just adjusting them sort of dynamically, as opposed to plotting the 3D space of scatters. You know what does that make sense?
No, I don't understand what you're saying. Come again, please.
I was wondering whether we could do something like this with heat maps by plotting 6 heat maps on the side of the cube instead of a whole set of three-dimensional points.
Yeah.
Whether you considered that option or if it was just like,
no, I mean, I actually also do that. So in some cases when the data is really high resolution, where you have a lot of points. So, and you only care about the faces, right? So in that case, I just subset that data and I create the heat maps for each one of the sizes.
Okay, thank you.
Actually, there is a tutorial here in Beautiful Makie. Sorry for the shameless advertisement, but so there's a tutorial on how to cube in Beautiful Makie where you actually put images in each one of the faces. So each one of these images could be a heat map as well. Yeah, that also works. Yeah.
If you have, I have some cases for plotting like this where a lot of the data is missing. So you should be able to see through to some of the cells in the middle. Is it possible to do this with having opacity on the cells for some that are missing? Or?
You could pass, I think you could pass the non-color keyword, right, Simon, to the call function, so that if the color argument here contains non-values, missing values,
yeah,
then you do non-color equals red or blue, and then you will see the missing values there, or transparent.
Yeah, of course, transparency works better than
yeah.
Actually, I have an example at the end where I use missing values, if I have time. Yeah. So let's see what does this one does. So Makie also contains this nice function which is called volume, where you don't need to do all these shenanigans about the mesh cutter thing. You just call volume over your 3D data, and you can get this volumetric plot for all your values as well. The only thing that I don't like about this one is that it's hard to see through it. But like they are too over exposed, like the colors here. You do this, I see a lot of red, and then I don't see a lot of details. And sometimes I actually like to explore pixel by pixel. So if I do the 3D one, which is the previous one, I can actually go below for my scatters, right? And actually explore each one of them and see where the values are or how they are actually. So, I mean, it's a matter of use case, right? So if you want to actually see each one of the values, then you do it like this. Or at least that's how I would do it. And I don't know, this one, display. I need to add display now everywhere. And the other function that is that I like more instead of volume is this pretty convenient function, which is called contour. So in contour, it works pretty well compared to volume, at least for me. And it looks pretty similar to the mesh cutter output, with the main difference that you can see that the values are interpolated between them, right? So I don't see the discreteness of my mesh cutters. So this one is the one that we usually use. Let me see the paper. Is that the one that we use here? Yeah, I think we use mesh contour here. Yeah, looks like contour. Yeah, not sure, but yeah, that's the one that I use. And yeah, this is basically it. So you could do the heat map, you could do the mesh cutter, then you could do the heat maps transformation also to get the cube, or you could use volume or contour. Okay, so depending on your use case, you should choose. The last example that I have is a little larger data set. Let me see. No, this is still. Let me run it. Display current figure, I suppose. Do I have the data already? Okay, no, I think this is too. Yeah. This is just another example. This is for a test. For a test data set. And Makie contains a lot of predefined themes. So you can just pass with theme black, theme ggplot, theme minimal, theme dark, theme black. And your whole plot will be theme with that theme. And yeah, this is, I remember what I did this plot. For the first data set, you only have 10 time steps, right? So you actually can do just each one of the heat maps and that's it. So you are done with your figure, you can put that into your publication. But if you have more slices in time, like 100, 1,000, then this becomes like really nice to explore. I mean, I can see all the slices here and see and have an overall view of the whole thing. So yeah, you can use the heat map with the transformation, the contour, or the volume, and you can explore that. And as my last example, I prepared this SAR file, which is also in the repo. If you instantiate your project and have everything there, you should be able to use JAX arrays and SAR. Speaking of SAR, sorry, I will take a small detour again. So if you go to JAX arrays, sorry, this is a package that I'm using to load the data. And then in JAX arrays, there is an example where you can open files of several gigabytes, right? And just load the data that you need to plot in demand, okay? This one is also using Makie, so yeah. So I just wanted to mention that you can work with big data sets with these two packages. And when you load the cube, you are actually not loading the data, everything's lazy, and yeah. should just work. And in this case, yeah, I'm loading my data. This case is pretty small, but this could be gigabytes. Yeah, whatever. And to do the heat map, I think it's display. Ah, I want to see the interactive one. Okay, I don't need it in this case because I just wanted to show that there is some data there. And the thing that was mentioned before, if you have a missing value, which in this case is encoded as a NaN value, we have this keyword argument, which is called NaN color. So if you want to actually see the amount of missing values that you have, you can put a color on them. So this last example is just to show this effect of having missing values. So if you go to your window, so you will have your slices, and where you have missing values, you will put a color. In this case, I put like a light blue color. So all these regions here are missing values, and as you rotate, you can see through the thing and actually do the exploration of your data set. So in order for this one to work like it's working now, you need to pass also transparency. So you put transparency here equals false. Then all the heat maps will be solid, so you will not see through them. And yeah, it will look like this. I mean, you will still see the missing values. So you go to the other side with the camera, but in the front you don't see them, right? So you need to play a little bit with the keyword arguments and yeah, to get the effect that you want. So I usually, if I have transparencies and I want to show something that I can see through, I put always transparency and things just work like this. Everything should be, yes?
I have a small question. Does it also work with missing? So the missing literal in Julia, or does it just work with none? The feature with that becomes transparent.
Correct me if I'm wrong, Simon, but for this one, I think only works with none.
Okay. Okay.
Yeah. Yeah, that's what I do, nans, basically. So, and that's it. I mean, if you have any questions or you are trying to work this out in your computer and it's not working, or you have some use case, just let me know and we can take a look at it. Okay. Thank you very much. And yeah, that's it. More questions? Oh, okay.
A raster data, and you had the elevation of it? How did you get elevation of raster to create a 3D?
What visualization are you talking about?
At the beginning.
At the beginning?
Yes, you had a.
This one?
Yes.
No, this one is just the heat map
okay,
data.
Okay. Okay.
So actually, you will have topography data as as the elevation data, and you can just pass this array of points and your values for your elevation data and call this function, and you will get this nice topographical plot.
Okay. Okay. Thank you.
Yeah. Actually, I think I did that one.
But I guess you could do that with any matrix whereby the value would be extruded, right?
It depends where you put your origin. So in this case, I put my origin at 0 so that all the markers start at 0. But you can also do it
Negative.
Negative, yes. Yeah. Actually, I have an example for that somewhere, but okay, sorry, but this is, I post most of my things on Twitter, so so that I can show off Makie to everyone. Okay, this is not working out, but I have something that works both ways, and it's for temperature. And yeah, you can see how it changes over time. All right, that's it. Thank you.
Thank you.